Welcome. Today we're going to talk about doing some trig identity proofs. We're going to start pretty basic and then kind of build our way up from here or from there. This is part one. Just some tips, some strategies for doing this. Just what I found helpful in all the years I've been doing this stuff. First thing, you got to know your identities. When they come to mind readily, when you just know them like you know the back of your hand, life is better. Secondly, what you're going to have is an equation where there's going to be something on one side you're trying to prove equal to something on the other side. Start with the side that looks really nasty and simplify it to look like the others. Again, doing so I think you'll be a lot happier than going the other way. Work on one side of the equation. Make it look like the other. Sometimes I found it helpful to take stuff instead of secants and cosecants and tangents. When you write it in terms of sines and cosines, good things typically happen. Sometimes it's helpful to express your quantities in terms of one function instead of, more than one. Algebraic techniques, the stuff you've learned how to do before, factoring, distributive property, common denominators, canceling, all that kind of fun stuff, it works. Sometimes doing so or multiplying by 1 in a useful way, like maybe you're multiplying by sine over sine or by like 1 minus cosine or something like that. Sometimes you can create Pythagorean identities out of something that normally would not be. Lastly, always try something. With practice, your success will improve, but try something maybe where you leads you nowhere, or you feel it leads you nowhere, but it may give you a clue as where you need to go from there. So don't give up on it. Just keep plugging away, and eventually you'll get there. Identities, again, the sooner you know them, the happier you're going to be. So I want to start with a couple basic ones I use a lot. Remember how I said to write stuff in terms of sines and cosines? So tangent can be written as sine over cosine, cotangent, cosine over sine. Your reciprocal identities, sine is reciprocal of cosecant, cosine is reciprocal of secant, and so forth. And then your Pythagorean identities. Typically, anytime you see either a 1 and a squared or a squared and a squared, those are usually going to be one of your Pythagorean identities. Okay, let's start with putting one into practice. First thing I've asked you to do here is to simplify. This is what we've done in our last lesson. So before we prove, let's just get good at simplifying. Now, as I look at this, on the right side, I see a 1 and a cosine. It's not a Pythagorean identity because there's no squared here, but I got cosecants and cotangents, so I'm going to write them in terms of sine and cosine. So using my reciprocal identity, I see cosecant can be written as 1 over sine. Cotangent can be written as cosine over sine. And then I'm leaving the 1 minus cosine alone. Now, looking over here, I have this fraction being added to this fraction. I do see they have common denominators, so I can put them together as one fraction or one ratio here. Now, from there, what I'm going to do is just put it all together. Take the top times the top over the bottom times the bottom. And when I distribute 1 plus cosine times 1 minus cosine, I get 1 minus cosine plus cosine minus cosine squared, and then all over sine. Okay, your plus cosine, your minus cosine cancel because basically on top you're looking at a difference of squares, giving you 1 minus cosine squared over sine squared. Again, when I see a 1 and a squared, that typically tells me to look in my Pythagorean identities, and 1 minus cosine squared can be expressed as one of those Pythagorean identities as sine squared. So I get sine squared over sine. If you cancel or reduce a sign on the top, one of the signs on top with the sign on the bottom, you get that it just simplifies down to sine x. Okay, that's simplifying. Here's proving. I'm not giving you this expression and say, what does it simplify down to? I'm telling you, here is this trig expression. Show me that it's equal to this trig expression. Now again, just what I've learned doing these a lot of times over the years, I'm going to pick the side that looks kind of nasty and go that way, and I'm feeling this thing with the rational number here, all this stuff on the top and all this on the bottom. I'm going to go with that route. Now, first thing I'm going to do is, I see here I have a 1 plus a sine minus a sine squared. I know that 1 minus sine squared is a Pythagorean identity, so what I'm going to do is change the order of these. So instead of saying I'm going to add a sine and subtract a sine squared, I'm going to use my commutative property of addition to say that 1 plus sine minus sine squared is really the same as 1 minus sine squared plus sine. Now, why do I want to group them differently like that? Because 1 minus sine squared does in fact give me a Pythagorean identity for cosine squared, and then I get here. Now to finish this off, here's where I'm at now. Always kind of keep in mind where you want to get. So here's what I have, here's what I want. So do I know any way I can take a cosine squared and a cosine on the bottom and get a cosine, and a sine over a cosine and get a tangent? Yeah. What I'm going to do is separate this fraction. Since there is one term on the bottom and two terms or more than one term on the top, I'm going to go ahead and separate them. Once I do, cosine squared over cosine, reduce top and bottom by cosine, you'll get cosine. Plus, this is one of your quotient identities, sine x over cosine x is tan x, which is what we're trying to prove that left side equaled from the beginning. So this turned into cosine x plus tan x, which was the right side of the equation, which is what we're trying to get. So game over. Okay, problem like this. I have an expression sine x over 1 plus cosine x equals 1 minus cosine x over sine x. I know I told you that the stuff you could do in an algebra class you can do here. I know you look at this and maybe you're saying, oh look, I can cross multiply this. You can't. The difference between what you did in algebra when you were like solving for a value of x or y or a, b or c, whatever it was, in problems like that, you were told that the expressions were equal, so you could use your properties of equality, cross multiplication being one of them, or cross products being one of them. But here, I don't know that these two quantities are equal. It's what I'm trying to show. So, in algebraic terms, it's legal to cross multiply when you have proportions if you're solving for another variable. It's not a good thing to do here because we don't know the two sides are equal. We're trying to establish that they are, so we're not going to go that route. So as far as picking a side that looks ugly, you know, 6 of one, half dozen of the other, neither one looks overly pleasant, I'm going to play with this right side, or this left side right here. And here's what I'm going to do. This is where I talked about multiplying by 1 in a useful way. So I have this sine x over 1 plus cosine. I'm going to multiply by 1 by writing 1 as 1 minus cosine over 1 minus cosine. Number one, this does equal 1, but why did I choose to write 1 in that form? It's basically because of this denominator. I know 1 plus cosine is not a Pythagorean identity, But if I multiply 1 plus cosine times its conjugate, 1 minus cosine, I know it'll turn into 1 minus cosine squared, which will give me a Pythagorean identity in a case where 1 did not exist at the beginning. So here's how I'm going to do this. I'm going to take this and I'm going to multiply it again. I'm working on the left side. I'm not touching the right side. My ultimate goal is to get this side to look exactly like that one. So here's where we left off. I'm going to leave the top like it is, and then on bottom I get 1 minus cosine squared, basically from distributing these two conjugates. Again, I know looking at the bottom we've created a Pythagorean identity, and I know 1 minus cosine squared is sine squared, correct? And then I'm going to reduce one of these signs on the bottom with the sign on the top, giving me 1 minus cosine over sine, which is what I was trying to prove. So we started on the left side, followed kind of those techniques I gave you earlier, and found that it did in fact equal the right side. Let's go and see if we can do one more here. I'm going to do this example number 4 here, and as far as picking an ugly side, right side looks nasty, left side looks nasty, I'm going to work with the left side. I'm going to try something a little different here, in that I'm going to take this cosecant. Again, I typically don't like working with cosecants and cotangents. I'm going to turn these using, number one, my reciprocal identity, that the cosecant is the reciprocal of the sine, minus my quotient identity that cotangent is cosine x over sine x. Again, what I'm looking at here is I see common denominators on the bottom. I am not doing a thing to the right side. I'm just bringing it down, and my ultimate goal is to make the left side look like that. So when I put these together, what I see is I get the same denominator, and here's what I have on top. Now from here, I think you're going to look at the problem I'm at. Looks an awful lot like what we just did in problem number 3. Again, I know you see this fraction on the left equal to the fraction on the right. I know you want to cross multiply. Don't. Instead, I'm going to multiply by 1 in a useful way, and I'm going to finish it up just like we did the last problem. So from here, treat it just like you did the last problem in example 3.